Hello and welcome back. So before we wrap up this section and start talking about NgRx entity, in this section I want to cover two more topics. One is NgRx runtime checks and another is meta reducers. So in this lecture we are going to learn what is NgRx runtime checks and when do we use it. NgRx runtime checks are basically a set of development time checks provided by NgRx store library that helps developers adhere to the core principle of NgRx and Redux, mainly related to state immutability, action immutability, and serializability. So we have learned that a reducer function should never mutate the original state. Instead, it should always return a new state. But that is just a principle which we must follow when we are working with NgRx application. So when we are creating a reducer function, we need to write the code in such a way that it does not mutate the current state. Instead, it returns a new state. But sometimes we as a developer, we might not do that. We might try to mutate the original state. And NgRx application will not complain about that by default. So the primary use of NgRx runtime checks is to shorten the feedback loop for common mistakes that can lead to subtle and hard to debug issues in NgRx applications. And by enabling these checks during development, NgRx will throw an error when a rule is violated. So for example, let's say we are trying to mutate the current state and that is the violation of NgRx rule. So in that case, these checks will simply throw an error telling the developer that it is not allowed. And this helps us developers maintain the predictability and reliability of our application state. So there are four main runtime checks which we can add in our NgRx application. And the first and the most important is strict state immutability. So we use this runtime check when we want to make sure that the reducer function does not mutate the original state. Instead, it should return a new state. So it should not modify, it should not mutate the original state. Instead, the reducer function should return a new state. Currently, if we try to mutate the original state, so let's go back to our application. And for example purposes, let's go to our counter component and there we have states, and in the states folder we have counter reducer. So if you see all these reducer functions, they are not mutating the original state. Instead, they are returning a new state. So it is taking all the values from the previous state and it is updating that state for which the value has changed. So here what we can do is, instead of extracting all the properties from the state object and then updating only the counter property, here what I can do is I can simply say return state, and before that I can say state.counter plus equals 1. So basically here I'm adding 1 to the current value of counter state. Okay, so here if you notice, we are not creating a new state. Instead, we are updating the original state. We are adding 1 to the counter property of the original state, and then we are returning the same state. So here we have updated the state and then we are returning that state. If I save the changes and if we go to our application, we should not see any error. Okay, and if I go to terminal also, the application has been compiled successfully. Now, the problem here is we are updating the original state. And when we are updating the original state, the one problem which we will face is we will not be able to do time travel debugging. And also, we will not be able to debug our application by going to previous states. So as a developer, we can make this mistake. But if we add a runtime check, and for that, let's go to AppModule where we have created our store. So here we are importing the store module in the imports array, and there we are passing our store name, which is app reducer. Here as the second argument, I can pass an options object, and in there I can use an option called runtime checks. And to this, we need to assign an object, and inside this object, we can specify the runtime checks. So for example, here I want to enable strict state immutability. So here we have strict state immutability. By default, it is false, but now I'm going to set it to true. And now if I save the changes, and if we go to our application, And here let's go to console. And where are we trying to update the original state? For the increment action, right? So for the increment action, we are trying to update the original state. So here, if I go ahead and if I decrement the value, we will not get any error. If I reset the value, we will not get any error. But if I try to increment a value, you will see that here we are getting an error, cannot assign to read only property counter. And this error we are getting because since we have enabled this strict state immutability check, it is not going to allow to mutate the original state, which we are trying to do here. Okay, but if we get back our code and let's save the changes now, and now let's go back to our application. And now if I click on this increment button, it is incrementing properly. So this check here, it makes sure that the original state does not get updated. And in the same way, we also have other checks. So for example, you will see that we also have checks like strict action serializability, strict action type uniqueness, strict action within NgZone, and strict state serializability. Now these two runtime checks, the strict action type uniqueness and strict action within NgZone, these are newly introduced. Basically, these are introduced after NgRx version 9, but other four were available for a long time. So here I have shown you a practical example of the use of this strict state immutability. Now let's theoretically learn about other runtime checks. So we already talked about strict state immutability. What it does is it does not allow us to update the original state. So here we are trying to update the original state, which is not valid. So if we have enabled this check, in that case, it will not allow us to update the original state. In that case, what we will have to do is we will have to create a new state like we are doing here, and then we have to return that new state instead of modifying the original state. Next, we have strict action immutability. What this runtime check does is it does not allow us to mutate the payload which we receive when an action is dispatched. So it verifies that action payloads are not mutated after they are dispatched. So for example, if you see this reducer function, it is handling an action. Let's say it is handling update user action. And with this action, we are also receiving a payload. In the payload, we have a user object. So here what we are trying to do is we are trying to update the last updated value of that user object. So here we are trying to mutate the payload object itself. But if we enable the strict action immutability check, then it will not allow us to mutate the action payload. Okay, so if this check is enabled, the action mutation rule will be violated and this runtime check will throw an error. So in that case, the right way will be to not update the original action payload. Instead, create a new payload. So here you see we are creating a new payload called user. And in that payload, we are extracting all the properties of the user object and we are only updating the last updated property with the current date and time. So instead of mutating the original payload, which is dispatched with the action, we are creating a new payload and we are updating that. So this strict action immutability check, it enforces us to not to mutate the original payload, which is coming with the dispatched action. Next, we have strict state serializability. This check makes sure that the data which we have in the state, that data is serializable. So the serialization means that all data in your state can be converted to a string value with the help of JSON.stringify, and those string values can be converted back to a JavaScript object. So for example, when we were saving the user data in the local storage, there we converted the user object to string type and then we stored it in the local storage. Now that was possible because all the data in the user object, they can be serialized. Now the data which cannot be serialized are functions, symbols, or data objects. So for example, let's say we have a state called last login date, which is of type date and time. So this data cannot be serialized. date object is not directly serializable. So for such state, if we have enabled strict state serializability, it will throw an error. Now the solution would be to, instead of storing the date, we can store the timestamp for that date. So I hope you already know what timestamp is. Timestamp is basically the date and time in milliseconds. So timestamp is nothing but a numeric value, and numeric values are serializable. So instead of storing a date and time value, we can store the timestamp of that date and time in the state, so that that state can be serialized. So to make sure that in this state we are only storing serializable data, we can enable this strict state serializability check. It will make sure that any data which we have in our state that can be serialized. If any data which cannot be serialized, this check will throw an error. Then we also have strict action serializability. So let's say whenever an action is dispatched, for that action, if you are dispatching any payload, that payload should be serializable. If you want to make sure that that happens, you can enable this strict action serializability check. So this check verifies that actions are serializable. Basically, the action payloads, they are serializable. And this is important for tools like Redux dev tools, which can record and replay actions. And actions with non-serializable payload cannot be properly replayed. So that's why whenever we are dispatching a payload with an action, we need to make sure that that payload has serializable data. And that can be done by enabling this strict action serializability check. So let's go to our application. And here, along with strict state immutability, let's also go ahead and let's enable strict action immutability. Let's set it to true. Let's also enable strict action serializability. Before that, I'm going to enable strict state serializability. Let's set it to true. Let's also enable strict action serializability, and let's set it to true. Okay, let's save the changes here. Now, as I said, apart from these 4 runtime checks, we also have 2 more runtime checks, and that is strict action within NgZone and strict action type uniqueness. Now, strict action within NgZone, what it does is it verifies that actions are dispatched within Angular's NgZone. If an action is dispatched outside of the NgZone, Angular's change detection might not be aware of the state change, leading to stale views. And this can be tricky to debug. Then strict action type uniqueness, it makes sure, it verifies that action types are not registered more than once. So if you remember, whenever we create an action, we use create action function, and there we pass 2 arguments. The first argument is the type of action. So basically there we specify a string value, and the second argument is the optional payload argument. And when we were talking about actions, there we also learned that every action must have a unique type. Now, if you do not enable this strict action type uniqueness, then for 2 different actions, you can specify the same type, and NgRx application will not complain about that. But if you enable this, in that case, if you have 2 actions with the same type value, NgRx is going to throw an error. So let's go ahead and let's also enable these 2 runtime checks. So here, let me enable strict action type uniqueness. I'm going to set it to true because I don't want 2 actions to have the same type. And finally, I'm also going to enable strict action within NgZone. Let's set it to true. With this, let's save the changes. So these are some of the runtime checks which helps you as a developer to avoid any unintentional changes to your application state or action payloads, and also for serialization purposes. This is all I wanted to cover in this lecture. If you have any questions from this lecture, then feel free to ask it. Thank you for listening and have a great day.